Okay, 2.7. Prove angle pair relationships. Use the properties of special pairs of angles. Here's a new theorem. 2.3. All right angles are congruent. Write a proof. Given JK is perpendicular to KL, and it's marked here with a right angle box, and ML is perpendicular to KL, and it is also marked. We need to prove that angle K is congruent to angle L. So we're going to write down our givens and say they are givens. And then we're going to say that angle, what does it mean to be perpendicular? Well, that means that angle K is congruent to angle L, that's what we're going to prove. Angle K and angle L are right angles, because that's what perpendicular means. And we know that angle K then is congruent to angle L, because all right angles are congruent. Pretty simple little statement. It's supposed to be a U here. My pen's not writing too well. Okay, theorem 2.4. If two angles are supplementary to the same angle, or to congruent angles, then they are congruent. If angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then angle 1 is congruent to angle 3. And then, theorem 2.5, if two angles are complementary to the same angle, or to congruent angles, then they are congruent. Angle 4 and angle 5 are complementary, and 6 and 5 are complementary, then angle 4 is congruent to angle 6. Okay, let's use this in a proof. So, given 1 and 2 are supplements, 1 and 4 are supplements, and the measure angle 2 is 45. Let's prove that the measure angle 4 also equals 45. Well, 1 and 2 are supplements, 1 and 4 are supplements. And that is because they are given. Now, what does that mean? That means that we can say that angle 2 and angle 4 are congruent, because congruent supplements theorem. Then we can also say that the measures are equal, because that is the definition of congruence. And we need to go, it seems like almost that these statements are the same, but we need to go down to the measures of it, because we're actually going to put numbers in now. And so we can say the measure angle 2 is 45, and we get that also from our givens. And so we can say that then measure angle 4 equals 45, because we can substitute in measure angle 4 for measure angle 2. Okay, checkpoint. See if you can do those. Start it again when you're through. Okay, postulate 12. If two angles form a linear pair, then they are supplementary. Angle 1 and 2 form a linear pair, so angles 1 and 2 are supplementary, and the measure of angle 1 plus the measure of angle 2 is, now remember, anytime that we use a little m, we're going back to numbers, so we know that's 180 degrees. Then theorem 2.6, vertical angle congruence. Vertical angles are congruent. Okay, here's our proof. 4 is a right angle. 2 and 4 are supplementary. So 4 is a right angle from given. And then what does it mean to be a right angle? So that means the measure of angle 4 equals 90 degrees, because it's a definition of a right angle. And then 2 is congruent to 4 because they are vertical angles. Okay, and then what can we say now? So we know that measure 4 equals 90 degrees, and we know that 2 is 4. So we could say that the measure angle 2 equals measure angle 4, and the measure angle 2 is 90 degrees because we can substitute in. Okay, and so angle 2 and angle 4 are supplementary because when you add them together, they equals 180. Okay, checkpoint. Try this one. Example 4. Find the angle measures. Write and solve an equation to find x. Then use x to find the measure angle FKG. Okay, because measure angle FKG and measure angle GKH form a linear pair, the sum of their measures is 180. 4x minus 1 plus 113 must equal 180. 4x plus 112 must equal 180. And we can do that because we are just simplifying. And then we can subtract 112 from both sides to get 4x equals 68. And then we can divide by 4 to get x equals 17. Now we're going to use x equals 17 to find the measure angle FKG. So FKG is 4x minus 1. 4 times 17 minus 1, and that is 68 minus 1, which is 67. Simplify. Okay, and then the final checkpoint.